Hello, mathletes. Let's exercise your brain. Let's fill up that irregular sphere with knowledge. In this lesson, we'll be talking about volume and rate of flow. But how do those two things relate? What is a rate? Let's review that before we get into the actual lesson. Well, just a little reminder that rate involves two quantities, two things, two measurements that correspond to each other. We usually write that as one quantity per the unit of another one. So let's talk about some examples of rates. Can you think of some? I'll give you a moment here to think of some. When you go to school or to the store or any activity with your family. So that example is speed, and we usually measure that in miles per hour. I know you probably thought of this one already, but math exercises, math problems per minute. That's in the context of speed, how quickly you do it. Now, how about a wage? Did you think about that one? You get a certain amount of money per hour or a certain amount of money per year. Oh, I bet you didn't think about this one. How about a rumor? We would usually measure that in people per day. And yes, there's a model for that. It's pretty interesting. Okay, I'm sure you have many more interesting ones, but the one that we're going to focus on today is the flow of water. And we could do that in liters per minute or liters per second or gallons per hour, whatever. But let's say that water flows into or out of a tank or into, a water collection system around your house or out of that water collection system into your garden at 50 liters per minute. Is that a lot? I don't know. Now we could calculate how much of that water has flowed in 1 minute, 2 minutes, 5 minutes, 10 minutes. And here's a quick little table for that. So if we have 50 liters per minute, well, in 1 minute we have 50 liters that have flowed. In 2 minutes, well, let's just double, so we have 100 liters. 5, can you do 5 times 50 in your head? I hope so. And then 50 liters for 10 minutes. Well, we like that one because all we have to do is multiply by 10 and we have 500 liters. And that's really the main thing that we're doing today is we're just thinking about the rate of the flow of water. And so let's take a look at the first example here. We have a tank that's filled from a faucet, and I like to use the idea of a water collection system, but it's not always consistent. And 200 liters flow into the tank in 5 minutes. The question is, how many liters will be in the tank in 8 minutes? Now, unfortunately, you can't just double that number, We can't just say 200 times 2, so 10 minutes is 400. But we could get an idea that it's actually less than 400 liters because of what I just said. Because if we go for 10 minutes, that's too long, and that's 400 liters. So if we get a number that's bigger than 400, we've made a mistake. What I like to do is just set up this as the unitary method. And if you don't know what that means or you forgot, that just means we're going to take what we know, 200 liters, and write it in a really shorthand notation, 200 liters in 5 minutes. And then we want to find out the units, like what is the amount of liters that flows in 1 minute. So I want to get down to 1 minute so I could go back up to 8 minutes. So how do I do that? Well, I have to divide by 5. And so if I divide 5 by 5, I have to divide 200 by 5. And since 5 goes into 20 4 times, and there's another 0 there, we have 40 liters in 1 minute. Now we're not there yet because we're going to do 8 minutes, yes? So let's go up to 8 minutes, and we'll do that in green. So how do we get from 1 minute to 8 minutes? Well, we have to multiply by 8. And if we multiply that 1 minute by 8, we have to multiply that 40 by 8. So what do we get? Well, 40 times 8. So 8 times 4 is 32 with another 0 hanging out. So that means we have 320 liters in 8 minutes. And we look at our little guide there, it's less than 400 liters. Nice work. Let's do one more. We're going to use the same rate of water, the same flow rate of 200 liters in 5 minutes. How long will it take to fill up the tank with 300 liters? I want to point out something that's unique here in that we're looking for the time but that's not the focus that we're going to have here. It's all going to be about the liters. All right, so now look back here at this first question. The question was about how many liters in 8 minutes. Now this question is how long for 300 liters. So our focus will be on liters. What I mean is that if we divide this 5 minutes down to 1, we're going to be multiplying by all sorts of numbers to get to what we want to for liters. So we're actually going to be converting the 200 liters down to 1 liter. So we have to divide that by 200. And if it doesn't make sense to you yet, it will in just a moment, you'll see. So we're going to divide that 5 by 200. And let's not worry too much about what that is. Let's just say it's 5 over 200 minutes, okay? And see what we could do next. All right, now what I was saying is that, hey, we're trying to get up to 300 liters, right? So now we need to take this 1 liter to get up to 300. All right, so that means we're going to multiply that by 300. So multiply both sides by 300, and we get 300 liters. That was our goal there, you see. So that the only way to get there was to divide by 200 and multiply by 300. All right, then what we have is basically a fraction problem. And we could totally do that. We could do 5 over 200 times 300. And what we'll do is kind of divide out some things in the process here. So let's do that. And I see a 0 there in the top and the bottom. I see another 0 in the top and the bottom. And what do we get? I have 5 times 3 over 2. And yes, it is a decimal. That's okay. 15 divided by 2. That's 16 divided by 2 is 8. So 15 divided by 2 is 7.5. 7.5 what? How long? Time. 7.5 times minute. All right, so notice the difference between those two questions. The first one, we were looking for how many liters. So that was not our focus. Our focus was working with the minutes. And then this one, we're looking for how much time. So our focus was on the liters and getting that down to the unit. Okay, and if you're confused about which one to use, you'll just try one. And if it doesn't get you what you need, then you'll do the other way. All right, so here's an official example. This is in your textbook page 58. A rectangular tank is filled with water, and here it is with the dimensions to its brim. And that's basically the top of the rectangular tank. And if the water is drained out at a rate of 12 liters per minute. I'll write that right away. And some books use that cursive little L. I'm using the big L here. So 12 liters in 1 minute. How long will it take to empty the tank? Now, because we're looking for the time, how long, we're actually going to focus on turning the liters into 1 liters. So the unit for liters. That's great. Okay, we have the unit for liters. 1 liter is going to take 1/12 of a minute. That's basically 5 seconds. 60 divided by 12 is 5 seconds. Now, but we kind of need to know like how much water is inside this tank, you know? So let's find out what that is. The volume of this tank is 80 times 50 times 60. And you could use a calculator for this, and you don't necessarily need to multiply this out, but you'll see when you could actually have done that. So that's 240,000 what? Centimeters cubed. Now remember that 1 liter is 1,000 centimeters cubed. So I'll circle that 1,000. I see 3 zeros, and I see 3 zeros over here. So what's left over on the left here is 240. And so I want you to see there's 1,000 centimeters cubed. And that right there, my friends, is liters. And I just want to recall the introductory video to this unit. I was sharing with you about how you're going to be doing multi-step problems. So here's a great example of a multi-step problem. First, we found the unit for liters, the rate in terms of liters. Then we found the volume of this rectangular tank. And not only did we do that, but we had to convert it to liters. And now we have to take that information So we're going to multiply by 240 on both sides here to get our final answer. So we're going to have 240 liters. How long does that take? I don't know. It's 240 times 1 over 12, or 240 over 1 times 1 over 12. And what I see is that I could take this 24. I know that there are two 12s in 24. Therefore, well, 240 liters, how long does it take? Well, it takes 20 minutes, because that's the multiplication that's going on right now. 2 times 1 over 1 times 1. 0 times 1. 20. There's a 20. See the 0? Okay. 20 minutes. That's how long, what, it would take to empty the tank. Okay, so good job. That's the main example right there. Now we'll have kind of a unique one here, and I just want to point out that the task, the whole question number 9 is worked out for you, so you could actually probably stop this video if you want to just read the example, but this is the last thing here. And if you want to just kind of think with me here, you could avoid looking at the textbook and work through it with me. And so we have a rectangular tank that has like these 4 gems, right? These great, powerful, super powerful gems, and they're metal cubes that have 5-centimeter edges. They're placed in this empty tank. So then the tank is filled, flowing from the tap at a rate of 6 liters per minute. So the first thing that I'm kind of thinking is that 6 liters in 1 minute, you know? And so how long will it take to fill up the tank? Well, first of all, I really do want to know what the volume of the cubes are. So I'll write out what those are, and that's 5 times 5 times 5. And there are 4 of them. So I could do 5 times 5 times 5. I should be able to remember that in my brain. 25 times 5 is 125 times 4 is 500 centimeters cubed. Oops. And my thought process at this point is like, okay, if I'm going to fill up that tank that's 20 by 20 by 11, then that means whatever the volume is of the tank, I need to subtract that 500, because as long as those don't float, you know, they're made of metal and they're not going to float at the top of that water, then those are just going to take up space inside of that tank. So let's just do the volume of the tank first, which is 20 times 20 times 11. You could do a calculator for that. That's basically 400 times 11, which is 4,400. And notice at this point I'm kind of diverging a little bit from your book. Now I want to communicate what is the total amount of water that would need to be filled. So basically we're taking that 4,400 minus the 500, which is 3,900 centimeters cubed. All right, and that's the key number right there, that 3,900. That's how many liters, not how many liters, but how much volume that's actually going to be filled. So that in terms of liters is 3,900 divided by 1,000. So that's 3.9 liters. And now your textbook actually takes that number and just divides it by 6, and you're like, wait a second, how did that even happen? Well, here's how. 6 liters in 1 minute. That means 1 liter in 1/6 minute. And now if we go up to 3.9 liters, that means 3.9 liters in, oh my goodness, 3.9 times 1/6, which is 3.9 over 6. And at this point, we just say what is that number? We just go to the calculator and say 0.65 minutes. So 65/100th of a minute. Oh my goodness. Maybe around 2/3 of a minute, which is 40 seconds. Okay then. Well, just to point that out, a major thing out here is that the focus of this question is not about these fractions down here. So if that causes you some issues, like we could totally work that out. But the key is just to see like that this big tank, that the volume is 4,400, and we need to subtract out those cubes and then use the unitary method down in the corner here. Okay, well, thanks so much for watching. I appreciate you filling your irregular sphere with knowledge with me. Have a great day, and Good luck on all your practice and all your work.